Hi students, this is Naveen. Today we are going to explain the force on dielectric slab whenever the dielectric slab placed between the two plates of a given capacitor. Today we are going to derive the expression force on the dielectric slab. Let's start the class. Let us assume I consider a capacitor and these two are the plates of the given capacitor. These two are the plates of the given capacitor. These two plates are separated by a distance of d, and the length of the each plate is a, and the width of the plate is b. Let us consider these are the two plates of a capacitor, and the length of the plate a, width of the plate b, the two are separated by a distance of d. It is clear? Now, if these two plates are connected to a battery, I will redraw the diagram here. First plate and second plate. Now, if I take one dielectric slab, this is the dielectric slab. This is the dielectric slab with a dielectric constant K. Now, I insert that dielectric slab between these two plates at a distance of x. I will insert this dielectric slab between these two plates at a distance of x. What is the remaining distance here? Side is a, remaining distance becomes a minus x. It is clear? If I connect the upper plate of the capacitor is to a positive charge, positive terminal, and negative terminal is connected to a lower plate of the capacitor, what will happen? Due to the connecting external source to the capacitor, the electric field induces between those two plates. The one plate becomes positively charged and other plate becomes negatively charged. This is the electric field direction from positive to negative. It is clear, but at the curves, nothing but at the ends of the plates or at the curves of the plates, the electric field is non-uniform, and the electric field, it is passing like this. The field lines is curved because of the edge effect, or we can say that the fringe effect. Due to the fringe effect, we got the electric field lines in a curved path. And one more thing, whenever the dielectric slab inserted between the two plates, what will happen? Due to the influence of the electric field, the opposite charge induced on the faces of the given dielectric slab. This is the dielectric slab. Due to this electric field, the opposite charges induced on the faces of the dielectric slab. Due to these two charges, what will happen? Both are attract to each other. Here, both are attract to each other. Due to these two charges, the exerted force, there is an exerted force. The force exerted like this. Due to the interaction of these two charges, the force exerted in this direction. Here, if you split this force into two components, this is the vertical component and this is the horizontal component. Here, if you observe, these two vertical components are same. If these two components are cancelled to each other or nullified to each other, what is the remaining component here? This is the horizontal component and this is also horizontal component. Due to this components, we have a resultant force in horizontal direction only. Finally, we got the force is in the direction in horizontal direction. Remember, due to these two charges, we have a force in this direction. If the force is split into the two components, one is the vertical component and another is the horizontal component. Here, The two vertical components are in opposite to each other. Both two are cancelled out or nullified, remaining the horizontal components. Due to that components, we exert the force in horizontal direction only. Finally, we got the force exerted on the dielectric slab between the capacitor in horizontal direction, and the force is in this direction. Due to this force, the capacitor pulls the dielectric slab inside. Due to that force, the capacitor pulls dielectric slab inside. See, this is the plates of the capacitor, and this one is the dielectric slab. The dielectric slab inserted at a distance of x between those two plates, and here finally got the force is in horizontal direction. That is the force. Now the capacitor is already connected to a terminals of the battery. The positive terminal is connected to a upper plate of the capacitor, and negative terminal connected to a lower plate of the capacitor. We already know that due to this it will become positively charged, due to this it will become negatively charged, and finally you got the force direction in horizontal. You can conclude that the force acting on the dielectric slab, it is inside the capacitor. Nothing but the capacitor pulls the dielectric slab inside. It is clear. Now we want to find out the expression for force. How to find out the expression for force? If you observe this material having some capacity, let's assume this material capacitance is C1, and here to here the capacitance of this material is C2. If you observe, these two capacitors are connected in parallel. First of all, we have to find out the effective capacitance of those two capacitors. We know that for parallel capacitors, what is the formula? C is equal to K epsilon naught A by D. From this, C1 is equal to, what is the K? If I take C1 here, this is the dielectric material with a constant K. If I take C1 here, the dielectric constant K epsilon naught. What is the area here? The total length of the capacitor plate is A, and this is X. The remaining length here A minus X, and the two plates are separated by a distance of D. Now K into epsilon naught, what is the area? X into what is the width of the plate? We already explained, this is the width of the plate. What is the width of the plate? It is B. I can draw like this, and this is the length of the plate, and this is the width of the plate. This one up the dielectric slab exerted up to here. This is X into what is the width of the plate? B. Instead of area, I can write Bx by D. This is C1. In same way, I can also written C2 is equal to K epsilon naught. But if you observe the C2, there is no dielectric material. If you consider the dielectric material is air, epsilon naught Bx by, but here there is no dielectric material, no need to write the K. If you write the K, if you substitute the, instead of K value 1, it will become epsilon naught A by D. Epsilon naught, what is the A here? Here length A minus X multiplied with, what is the width of the capacitor plate? Nothing but what is the width here? B. And here this width and this width both are same. The width of the dielectric slab, the width of the capacitor both are same. It will become A minus X multiplied with B by D. What you got here? C1 is equal to K epsilon naught Bx by D. C2 is equal to epsilon naught of A minus x of B by D. If you observe these two capacitances connected in parallel, if the two capacitors are connected in parallel, what is the effective capacitance? Effective capacitance is equal to C1 plus C2. Here C1 is equal to K epsilon naught Bx by D plus C2 is equal to epsilon naught A minus x of B by D. If you observe the epsilon naught B, here epsilon naught B by D is common terms in both two C1 plus C2. Epsilon naught B by D taken as common, and remaining x plus Kx plus A minus x. From this, C effective is equal to epsilon naught B by D. Here how can I write? A plus, I can take x as a common term, x of K minus 1. This is the effective capacitance of the given plates, or this is the effective capacitance of C1 plus C2. But our main requirement is to find the force. How to find out the force? First of all, you have to find out the effective capacitance. After that, you have to find out the energy stored in capacitor. By using energy stored in capacitor, we are able to find out the force exerted on the dielectric slab whenever it is placed between the two plates of a given capacitor. From this, what is the energy stored in capacitor formula? Energy stored in capacitor. What is the formula? We know that U is equal to of CV square. Here C is nothing but effective capacitance. Of into, instead of C you can write C effective epsilon naught B by D A plus x of K minus 1. And this C effective multiplied with V square, we can also written as epsilon naught B V square by 2D multiplied with A plus x of K minus 1. This is the energy stored in capacitor. Whenever the capacitor connected to a external source, this total equation having the condition is here the capacitor connected to a external source. If the external source is not there, expressions are different. If the external source is there, this is the expression. It is clear. By using this this energy stored in capacitor, we have to find out force. We know that force is equal to, what is the formula, what is the relation between force and energy stored in capacitor? F is equal to minus du by dx. From this I can also write F is equal to minus d by dx of, what is the u value here? Epsilon naught B V square by 2D multiplied with A plus x of K minus 1. It is clear. Now we have to find out the differentiation of this one. Finally got the force acting on the dielectric slab. How to find out the F value? F is equal to, I will take out this one, epsilon naught BV square by 2D, and we can also write d by dx of, it is minus d by dx of A plus x of K minus 1. From this, F is equal to minus epsilon naught BV square by 2D. What is the, I can also written as d by dx of A plus d by dx of K into x, kx minus d by dx of x into 1, that is x. It is clear. F is equal to minus epsilon naught b v square by 2d. D by dx of a, it will be 0. D by dx of kx, it gives k only, minus d by dx of x. D by dx of x means becomes 1. Finally I got f is equal to minus epsilon naught b v square by 2d multiplied with k minus 1. This is the formula for force exerted on dielectric slab. Whenever the dielectric slab placed between the two plates, if the external force is connected to the capacitor, this is the force formula. By observing this equation, we can easily say that here the force is constant. Force is constant. Is that clear? Till now, we are finding the expression of force whenever the external force is connected to a capacitor. Per suppose, if the external force is disconnected, external voltage source, nothing but if the external source is disconnected, if there is no external source connected to a capacitor, how to find out the force? If there is no external source connected here, we have to find out the force. No external source is connected here. If external source is disconnected, here these two capacitor plates having a charge. Let us assume this is plus Q and this is minus Q, and you already know that effective capacitance. What is the effective capacitance formula? You already get epsilon naught. What you got? Epsilon naught. What is the effective capacitance formula? We already know that C1 is equal to epsilon naught by D and C2 is equal to epsilon naught A by D. I will write one more time. C1 is equal to epsilon naught A by D. From this we already know epsilon naught. What is the area? Bx by D, and C2 is equal to epsilon naught A by D, and first C1 having a dielectric constant K, and second C2 the dielectric material is A, the dielectric constant K is equal to 1. Here I will write epsilon naught A minus x of B whole by D. Finally got C effective is equal to epsilon naught B by D is a common term. From this how can I write Kx plus A minus x. We already derived this one more time I will show you. C effective is equal to epsilon naught B by D. How can I write A plus x into K minus 1. It is clear? This is the effective capacitance of these two materials. Now, by using this, how to find out the force acting on the dielectric slab whenever there is no external source connected to it? Simple. Same. First you have to find out energy stored in capacitor. Energy stored in capacitor. What is the energy stored in capacitor formula? U is equal to half CV square. But if you observe here, there is no voltage source, there is no external source connected here. U is equal to half into, you can convert this equation in the form of charges Q square by C. Therefore, U is equal to half into Q square. What does C here? Epsilon naught B by D multiplied with A plus x of K minus 1. It is clear? From this, what is the energy stored in capacitor? Q square D by 2 epsilon naught B multiplied with A plus X of K minus 1. This is the energy stored in capacitor, but our requirement is you have to find out force exerted on the dielectric slab whenever it is inserted in between the two plates of the capacitor. Here the condition is there is no external source is connected to a plates of the given capacitor. Till now we have U is equal to Q square D by 2 epsilon naught B multiplied with A plus of X of A plus X of K minus 1. How to find out the force? We know that force is equal to minus du by dx. From this I can also write as force is equal to minus d by dx of, for the u value, Q square D whole by 2 epsilon naught B multiplied with A plus X of K minus 1. It is clear? From this we can also write as F is equal to Q square D by 2 epsilon naught B. This is minus multiplied with D by dx of A plus X of K minus 1. Now we have to find out the differentiation of this one. After that you have to multiply with this one. Finally you got force acting on the dielectric slab. Is that clear? Now we are going to differentiate the terms. Now how to find out the differentiation? F is equal to minus Q square D by 2 epsilon naught B. If you observe, it is in the form of d by dx of 1 by f. If you observe, the equation is in the form of d by dx of 1 by f. How can I write this one? It is also written as minus d by dx of f whole by f square. By applying this, I can write as minus d by dx of, what is the f here? A plus x of K minus 1 whole by f square, nothing but A plus x of K minus 1 whole square. It is clear? And f is equal to minus Q square by D by 2 epsilon naught B multiplied with, see here minus and minus, it will become plus, no need to write, d by dx of A. What is the d by dx of A value? 0 plus k into x kx, d by dx of kx k, and d by dx of x into 1x, d by dx of x. What is the value? It will be 1. It will become minus 1. Minus sign is there. Whole by A plus x of k minus 1 whole square. Is that clear? This is also written as F is equal to Q square D by 2 epsilon naught B multiplied with k minus 1 by A plus x of k minus 1 whole square. This is the final force formula. This is the force on dielectric slab. Whenever the dielectric slab placed in here, two plates of the capacitors, if there is no voltage source is connected, this is the force formula. If you observe, this force is not a constant, and this force is not a constant. Is that clear? In this class, we explained that force on dielectric slab. First, we have to take one dielectric slab and you have to insert the dielectric slab. After that, we are finding the force, that is the horizontal force exerted on the dielectric slab. the capacitor pulls inside the dielectric slab. After that, we are going to find out the C effective. From the C effective, we have to find out energy stored in capacitor. After that, we have to find out the force by using the relation between energy and force. Finally, you got the force on dielectric slab whenever it is connected to the external voltage source. In next case, if there is no external source, this is the formula for the force on dielectric slab. Is that clear? Thank you all of you.